Hello friends, welcome to Geeky Rabbit. Welcome to a series on Docker. So today we will be seeing about the persistent data and the different storage options that are available in Docker. So let us start. Containers are generally immutable and ephemeral in design. In other words, these are just another terms for the unchanging, temporary or the disposable data. Whenever the containers are being set up, the unique data associated with it also comes in picture. So what happens to this unique data that the app produces? It can be the databases, key value store, or any other unique data. Ideally, the container should not contain the unique data mixed in with the application binary. This is called as the separation of concern, and Docker gives us a huge benefit in here. With the help of Docker, it is possible to update our application by recreating a totally new container with the newer version of our app, and the unique data will be available as it was before. It was being preserved while the container was being recycled. So whatever containers that we run, its unique data is preserved even if we stop them. It will be only removed when we remove the container. That is when the UFS layer will go away. But that can be done at the R will, and this problem of maintaining the unique data is also known as persistent data issue in the Docker world. So containers are generally lightweighted, and when unnecessary data is added, it will make the container heavy to create and run. Docker has its way to mount storage from the host machine to the container. So Docker provides three ways to mount the data to the container, that is the volume, bind mounts, and the temporary file system storage. Volumes are part of the host file system, but managed by the Docker at the specific path and cannot be modified by other application, or should not be modified by other applications. Bind mounts can be placed anywhere on the host, but can be modified by other applications. Lastly, temporary file systems are in the host in memory space, and they never get written into the file system. Now, let us look at them one by one. So first of all, we'll see about volumes. Volumes are the preferred mechanism for persisting data generated by and used by Docker containers. While bind mounts are dependent on the directory structure of the host machine, volumes are completely managed by Docker. Volumes have several advantages over the bind mounts, which are: volumes are easier to backup or migrate than bind mounts. You can manage volumes using the Docker CLI commands or the Docker API. Volumes work on both Linux as well as Windows container. Volumes can be more safely shared amongst multiple containers. Volume driver let you store volumes on remote host or cloud provider to encrypt the content of volume or to add other functionality. New volumes can have their content pre-populated by a container. In addition, volumes are often a better choice than the persisting data in a container writable layer, because the volume does not increase the size of the container using it, and the volume's content exists outside the lifecycle of a given container. Also, if your container generates non-persistent state data, consider using a temporary file system mount to avoid storing the data anywhere permanently and to increase the container's performance by avoiding writing into the container's writable layer. Now let's move on to bind mounts. They have been around since the early days of Docker. Bind mounts have limited functionality compared to volumes. When you use a bind mount, a file or directory on the host machine is mounted onto a container. The file or directory is referenced by its full or relative path on the host machine. By contrast, when you use a volume, a new directory is created within Docker storage directory on the host machine, and the Docker manages the directory contents. Volumes and bind mounts let you share files between the host machine and the container, so that you can persist data even after the container is stopped. So if you are running Docker on Linux, you have a third option, that is the temporary file system mounts. When you create a container with temporary file system mount, the container can create files outside the container's writable layer. So with this, we come to an end of this video in the series, which was on storage option in Docker, part 1. In the next lecture, we will do a hands-on on the things that we saw today, that is volume and bind mounts. Also, hope you have liked today's content, and do comments in the below section with your any suggestions or any questions. So see you soon with more Docker related content. Until then, have a good day. Thank you.